Hello, eighth graders. Welcome to week 9. We're going to be talking about atoms all throughout the week. Today, students should be able to determine and identify the atomic numbers and mass numbers of various atoms. So that's our learning target. Athletes wearing the same colored jerseys are all on the same team. In addition, each player's jersey has a unique number to distinguish him from his teammates. Imagine how confusing it would be if members of both teams wore the same colored jerseys and all the members of a team had the same number on their jerseys. How could you tell the athletes apart? It's often useful to have ways to signify different people or objects like athletes on teams. The same is true of atoms. It's important to be able to distinguish atoms from one element from atoms of another element. Elements are pure substances that make up all other matter, so each one is given a unique name. The names of elements are represented by a unique 1 or 2 letter symbol, such as H for hydrogen, C for carbon, He for helium. The table we saw is called the periodic table of elements. Each symbol stands for a different element. What do you think the K symbol stands for? What does K stand for? The symbol K stands for the element potassium. The symbol comes from the Latin name for potassium, which is kalium. Many of the elements that we have on our elemental table do come from Latin. The symbols in the table above would be more useful if they were revealed more information about the atoms they represent. For example, it would be useful to know the numbers of protons and neutrons in the atom. That's where atomic number and mass come in. The number of protons in an atom is called its atomic number. This number is very important because it is unique for atoms of a given element. All atoms of an element have the same number of protons, and every element has a different number of protons in its atoms. For example, all helium atoms have 2 protons, and no other elements have atoms with 2 protons. In the case of helium, the atomic number is 2. The atomic number of an element is usually written in front of or slightly below the element symbol, like we see here. Atoms are neutral in electrical charge because they have the same number of negative electrons as positive protons. Therefore, the atomic number of an atom also tells you how many electrons the atom has. This, in turn, determines many of the atom's properties. There's another number in the box above for helium. That number is the mass number, which is the mass of the atom in a unit called the atomic mass unit. One atomic mass unit is the mass of a proton, or about 1.67 times 10 to the negative 27th kilograms, which is an extremely small mass. A neutron has just a bit more mass than a proton, so its mass is often assumed to be 1 atomic mass unit as well. Because electrons have virtually no mass, just about all of the mass of an atom is in its protons and neutrons. Therefore, the total number of protons and neutrons in an atom determines its mass in atomic mass units. Consider helium again. Most helium atoms have 2 neutrons in addition to 2 protons. Therefore, the mass of most helium atoms is 4 atomic mass units. 2 AMU for the protons and 2 AMU for the neutrons. However, some helium have more or less than 2 neutrons. Atoms with the same number of protons but different numbers of neutrons are called isotopes. Because the number of neutrons can vary for a given element, the mass numbers of different elements or different atoms of an element may also vary. For example, some helium atoms have 3 neutrons instead of 2. Therefore, they have a different mass number than the one given in the box above. So, question, what is the mass number of a helium atom that has 3 neutrons? Take a second and think about that one. If a helium atom has 3 neutrons instead of 2, what should its mass number be? Think you got it? Let's check. The mass number is the number of protons plus the number of neutrons. For helium atoms with 3 neutrons, the mass number is 2 protons plus 3 neutrons, for a total of 5. We were working with helium-5, a radioactive isotope of helium. How would you represent this isotope of helium to show its atomic number and mass number? Little disclaimer here. The half-life of helium-5 is 2 × 10 to the negative 21 seconds, which means it expires in far less than a second. You would never have time to fill a balloon with it. So back to the question, how would you represent this isotope of helium to show its atomic number and mass number? Helium-5. You would represent it by the element symbol and both numbers with the mass number on top and the atomic number on the bottom. In summary, elements are pure substances that make up all matter, so each one is given a unique name. The names of elements are also represented by unique 1, 2, or sometimes 3 letter symbols. The number of protons in an atom is called its atomic number. This is also unique for each element. An atom's mass number is its mass in atomic mass units, which is about equal to the total number of protons and neutrons in the atom. Different isotopes of an element have different mass numbers because they have different numbers of neutrons. So, back to our learning target. Are you able to determine and identify the atomic numbers and mass numbers of various atoms? If you'd like more practice, feel free to go back and view the video again. Otherwise, go ahead and move on to the next assignment.